Hello guys, and welcome to Electronics Tutorial 4. And today we're going to be learning about a very useful skill called Ohm's Law. It's a mathematical equation. It helps you calculate something like a resistor for what resistor you would need for this LED. It's a very simple formula, but it helps you find out what resistor you might need for an LED. Such as we have all these resistors here, but we don't know which one to use for the LED. And we need to choose the correct value so we don't give too much power to the LED or don't not give enough power. So that's what we're going to be learning about today. So welcome guys. So today we're going to be learning about one of the most useful formulas in electronics, and it's Ohm's Law. And it goes V is equal to I multiplied by R. And you may be wondering what each thing equals. Well, V is equal to the voltage, and I is equal to the current, and R is equal to the resistance. And as we remember, current, which is I, is measured in amps, voltage is measured in voltage, and resistance is measured in ohms. And it's a very useful formula, and it's very easy to calculate the value of a needed resistor for something like a LED. You can easily use it for a lot more things, anything. And it's very useful because it's a very simple formula and it's always true. So you can find that if you multiply the current by the resistance, it will always equal the voltage in the circuit. And you can flip that formula around another way to calculate, let's say, the needed resistance. So we divide I by both sides, that's the current, and we get V divided by R is equal to the V divided by I, which is voltage divided by current, is equal to resistance. So using that very simple formula, we're able to calculate any needed and then the resistance or what the voltage or current will be at any point in the circuit. So guys, this is an example of Ohm's Law. We're going to be using it to find which resistor we need for an LED. So remember how in the previous videos we've been using resistors for LEDs, and how I calculate which resistor we need is I use Ohm's Law as we learned before. And if you remember, it's V equals IR, where voltage is voltage, I is current in amps, and resistance is resistance in ohms. So if we can quickly find the resistor value by dividing both sides by I, and we get V over I is equal to R. So now we plug in our numbers. So the voltage that we're using, the voltage that I use is 3 volts. So we do 3 divided by the current in amps. And in amps, 25 milliamps. 25 milliamps is the amount of current I need for my LED, and I got that from my data sheet online for my LED. And so we do 3 divided by 0.025. And the reason we do that is because we have to do everything in amps, and 25 milliamps in amps is 0.025 amps. So we do 3 divided by 0.025, and if we do that, let me see, what would that be? It would be, so that would be, I think around a 120 ohms, let me see. Yeah, so that would be right. So that would equal 120. 0.025 into 3 goes in 120 times. So we find out the resistance we need for our LED in order to give it only 0.25 amps of power, and that's the recommended power for it. We have to use a 120 ohm resistor on. And unfortunately, I don't have any 120 ohm resistors, but I have a 110 ohm resistor, and that's good enough. So let's actually go over to the breadboard and see how that looks. So guys, we're back, and remember we learned in the previous clip, we learned that in order to find the correct resistor value for an LED, we needed to find how much milliamps of power it needed and the voltage we're going to be using, and therefore we can find the right resistance by using V divided by current is equal to the resistance. So now we are going to actually use that LED we have right here. And first I'm going to show you what happened if we put one without the resistor. So here, let me get another red LED. So as we can see here, if you guys can see here, let's plug this in. Let's actually go to a little closer view. So as we know, on my two breadboard rails, the positive and negative, I have the positive hooked up to the 3-volt power supply, and the negative hooked up. So we're going to stick the LED in and see what happens. So let's actually stick it in and then give it power. So we're going to stick this up and now give it power. So as you can see, it goes very bright and then starts dimming down. And if we left it for a little bit longer, it would have been completely burnt out. And that's because we're giving it too much current. And that's with LEDs, since they don't have a restriction on how much current they let in. They just let in as much current as possible. And you can't feel this LED, but this is very hot right now. I'm touching it and it's burned to the touch. Wow. So you can see a resistor is very necessary. So we're not going to use that in the LED anymore, but luckily I have plenty more. So let's get another red LED. And let's use I actually don't unfortunately have a 120 ohm resistor we calculated we needed, but I have a 110 ohm resistor, which is close enough. With the resistor value, it really doesn't have to be completely accurate. It can be just within 20 to 40 ohms of what. Hello guys, and we're back with our breadboard here. So now we're going to be implementing the formula we did to find the calculation for this LED. I know this is a long video and it's or long for this topic, just to light an LED, but it's important because you learn the basics of what resistor to choose, and the formula to find that. So now we're gonna do this. We're gonna hook up the positive leg of our LED, which is this one on the right. You can't see it, but it's the longer one. Remember, that's positive. And we're gonna use our 110 ohm resistor. We calculated we need 120 ohms, but 110 ohms is pretty close to that, so that should do. We're going to connect that to the positive. Get that in there. So, and then we're going to hook our other leg to ground. And that's the negative rail on our breadboard. So let's plug that in. Let's plug our LED in. And it should lights up very nicely. So it's kind of hard to see on this, but the LED is a very nice brightness. It's not too bright. It's not too dim. And looks pretty nice. So that was a pretty basic video on Ohm's law, just to find out how to calculate for an LED. This is a very important formula. You're going to be using it a lot in electronics, and you have to know how to use it pretty quickly. So let's say you're building a big project and you need to find out which resistor to use in somewhere in a complex circuit, and you need to quickly utilize this formula. It's a basic formula, but it's a very useful formula, and it's essential to know in electronics. Thank you for watching, guys, and we'll see you next week on this is actually the end of our video, end of our series on basic electronics. Next week we're going to be moving into some more stuff on the Arduino. If you don't know what that is, it's a very useful microcontroller you can use to interact with real-world sensors. And here, let me actually show you one right here. I have just to kind of get you excited about the next video. So this is a Arduino right here. Let's actually move this out of the way. This is a Arduino. This is actually an Arduino Mega, and it may look pretty complex, but it's very easy to use. And you can interact with real-world sensors and things like LEDs. Like you can make an LED blink. You can run a motor. You can run a servo motor. You can run an LCD display like this one, writing characters on it. You can interact with speakers like this one right here, and make specific sounds on it. You can interact with let's see, LEDs, push-button switches like these. And it's so important because you can also interact with sensors and read data like this photoresistor, which measures light. And you can interact with it and make something happen. So let's say the photoresistor detects light, then you can make a motor start running. And it's a very useful thing. and there's wireless communication with Arduino, and we're going to get into that into the next series as we learn about everything about Arduino. And I'm also on the side, if you don't want to learn about this microcontroller and more about some other things, I'm also starting our series on intermediate electronics. We're going to cover things like transistors, passive and active filters, and some just more things on such as things as like logic gates. And it's going to be very useful, but we're also going to have the Arduino series running at the same time, so you guys can learn all about that stuff. And we just want to get you more educated about electronics and how fun it is to build really cool projects. So I'll see you next week, guys. Have a great night.